In September 2025, a routine survey of main belt asteroids captured something unusual about object number 31 Atlas. Its rotation pattern defied every model of natural tumbling. The spin axis shifted in ways gravity and collision physics cannot explain, as if guided by an internal mechanism, not the chaos of deep space. If 31 Atlas is moving with purpose, steering itself through the asteroid belt, then humanity may be facing its first confirmed encounter with alien technology. What intelligence designed this object? And what is it doing in our solar system? In December 2025, data streams from 3 separate observatories converge on a single conclusion. The rotation of 31 Atlas is not random. Radio telescopes in Australia, optical arrays in Chile, and radar installations in California all track the same object over consecutive nights. Each facility operates independently, using different methods, yet their measurements align with unsettling precision. The asteroid completes one full rotation every 7.3 hours, a period stable to within milliseconds across months of observation. But the orientation of that spin changes week by week. The axis itself is precessing, tracing a slow circle through space. In natural asteroids, this kind of precession follows predictable patterns tied to internal mass distribution and external gravitational torques. Music. Here, the precession rate accelerates and decelerates in cycles that match no known model. The axis shifts by 0.3 degrees per week, then slows to 0.1 degrees, then accelerates again. The pattern repeats with a period of roughly 90 days, far too regular to be coincidental. Astronomers working with radar data from Goldstone Deep Space Network detect another anomaly. When radio waves bounce off 31 Atlas, the returning echo shows a surface that is unusually smooth on one hemisphere and jagged on the other. The smooth section reflects radar with an efficiency nearly 40% higher than typical stony asteroids. This suggests a material composition unlike common silicates or carbonaceous rock. Music. Spectroscopic analysis from the European Southern Observatory adds another layer. The reflected sunlight from 31 Atlas contains absorption features that don't match any known mineral assemblage. There are hints of refined metals, alloys that require temperatures, and processes not found in natural asteroid formation. Iron-nickel compounds mix with trace elements like titanium and chromium in ratios that suggest industrial refining, not cosmic accident. Music. Independent research teams begin sharing their findings through secure channels and academic networks. Within weeks, a picture emerges that no single observation can capture alone. 31 Atlas is not behaving like a rock shaped by 4 billion years of collisions and solar wind. It is behaving like something with internal structure, possibly with active components still functioning after an unknown journey through interstellar space. NASA's Center for Near-Earth Object Studies maintains orbital records for thousands of asteroids. When analysts pull the historical trajectory of 31 Atlas, they find something that should have triggered alerts years ago. The object's orbit is too circular, too stable. Most main belt asteroids show eccentric paths shaped by gravitational interactions with Jupiter and Mars over millions of years. 31 Atlas moves in an orbit with an eccentricity of just 0.04, nearly circular, with an inclination of only 2 degrees to the ecliptic plane. This places it in a zone of maximum stability, a gravitational sweet spot where perturbations from giant planets cancel out over long timescales. The odds of a random collision fragment ending up in such an orbit are vanishingly small, less than 1 in 10,000. Music, but there's more. When orbital integrations are run backward, tracing where 31 Atlas might have been 1 million years ago, the models struggle to find a parent body or impact event that could have placed it on this path. The orbit appears designed, not inherited, as if something chose this trajectory for long-term stability and minimal energy expenditure. JPL engineers calculate the delta V, the change in velocity needed to shift 31 Atlas from a typical chaotic asteroid orbit into its current path. The number comes to roughly 340 meters per second. For an object with an estimated mass of 2 trillion kilograms, that requires energy equivalent to a small nuclear arsenal. No natural process in the asteroid belt delivers that kind of precise impulse. Music. The implications hang in the data, like a question no one wants to ask aloud. If 31 Atlas arrived from outside the solar system and maneuvered itself into a stable parking orbit, then its presence is not accidental. It is waiting, observing, or perhaps dormant, conserving energy in a region where it can remain undisturbed for millennia. Dr. Mira Patel, an astrobiologist at the SETI Institute, reviews the accumulated evidence with a team of engineers and planetary scientists. They focus on the precession anomaly, the controlled axis shift that repeats every 90 days. Patel proposes a mechanism that makes the room go quiet. If there are internal gyroscopes or reaction wheels still operational inside 31 Atlas, they could adjust the spin axis without expelling mass. That would explain the precision and the cyclical nature of the precession. It's exactly what you'd expect from a probe designed to reorient its antennas or sensors periodically, scanning different regions of space. Music, the hypothesis is testable. If 31 Atlas contains active momentum control systems, then the precession cycle should correlate with its position relative to Earth, the Sun, or specific star fields. Patel's team pulls the orbital data and overlays it with the precession timeline. The match is immediate and striking. Every time 31 Atlas completes a 90-day cycle, its spin axis has reoriented to point toward a region of the sky near the constellation Lyra. The alignment is not perfect, but the trend is undeniable across 4 consecutive cycles. The object is not randomly tumbling. It is aiming at something or listening for something in a specific direction. Music, if this is a probe, then its builders designed it to operate autonomously for durations that dwarf human timescales. The stable orbit, the controlled precession, the refined materials, all point to engineering principles focused on longevity and minimal intervention. A machine built to last millions of years in the harsh environment of interplanetary space. The mathematics of the situation tighten the case further. Engineers at MIT analyze the energy budget required to maintain the observed precession cycle. If 31 Atlas is using internal flywheels to adjust its orientation, the power draw would be minimal, on the order of a few watts. A small radioisotope thermoelectric generator, similar to those used in deep space probes like Voyager, could sustain such a system for hundreds of thousands of years. Thermal imaging from infrared telescopes shows that 31 Atlas has a slightly elevated surface temperature compared to neighboring asteroids at the same distance from the Sun. The difference is small, just 3 to 5 Kelvin, but consistent across multiple observation campaigns. This excess heat could be waste energy from internal systems, slowly radiating into space. Music, the numbers align with a machine in standby mode, not fully active, but not entirely dormant either. A probe designed to wake under certain conditions, conserving power until a signal is received or a specific event occurs. The thought experiments that follow are unsettling. If 31 Atlas has been waiting in the asteroid belt for millennia, what is it waiting for? And has humanity's recent activity in space, radio transmissions, spacecraft traffic, already triggered a response we have yet to detect? Music, radio astronomers at the Allen Telescope Array in California begin a dedicated monitoring campaign in early 2026. If 31 Atlas is transmitting, even weakly, the signal would be detectable at frequencies commonly used for deep space communication. The telescopes point toward the asteroid during its optimal viewing windows, scanning a wide-band electromagnetic spectrum. For 3 weeks, the results are negative. No coherent signals, no modulation patterns, just the natural radio noise of the cosmos. Then, on the night of January 18th, a narrowband emission appears at 1.42 gigahertz, the hydrogen line, a frequency widely considered a universal channel for interstellar communication. The signal lasts only 17 seconds. It pulses 3 times, each pulse separated by exactly 2.718 seconds, a number unmistakably close to the mathematical constant E. The transmission then cuts off, and despite days of continuous monitoring, it does not repeat. Music, the detection is reviewed, verified, and cross-checked against satellite interference and terrestrial sources. The signal's origin is consistent with the position of 31 Atlas to within the resolution limits of the telescope array. The timing, the frequency, the mathematical structure, none of it can be easily dismissed as natural. If the signal is real, and if it came from 31 Atlas, then the object is not a derelict. It is active, capable of intentional communication, and possibly aware of Earth's growing technological presence. The implications cascade through the scientific community. A probe that listens and responds. A machine that has waited in silence for longer than human civilization has existed. The question shifts from whether 31 Atlas is artificial to what its presence means. If it is a probe, who sent it, and when? Stellar dynamics suggest that 31 Atlas, if it entered the solar system from interstellar space, would have taken millions of years to reach its current stable orbit. The builders of such a machine would need to think on timescales that dwarf the rise and fall of entire species. Music, the technology required to build a self-sustaining probe capable of operating for millions of years in deep space, exceeds anything humanity has achieved. Yet the evidence suggests that such a thing exists, hidden in plain sight among the numbered asteroids of the main belt, mistaken for a rock until the data refuse to cooperate with that assumption. As observation campaigns continue and new instruments are pointed toward 31 Atlas, the scientific community faces an unprecedented challenge. How to study something that may be studying us back. How to interpret signals and behaviors from a machine designed by minds that may think in ways utterly alien to human cognition. Music. Every new data point raises more questions than answers. The cosmos keeps revealing phenomena that don't fit old categories. Today, the boundary between natural and artificial blurs, and the sky reminds us that our solar system may not be as empty as we once believed. What do you think?